how about now? Sweet, this is working. 30 minutes ago, I did not think this was going to work. Cool, so we'll wait a few minutes. Basically what I've got is the 2012 released exams, so I can actually stream them. I don't think I can stream anything that's secure legally, but most of these we haven't used, so we'll just kind of talk through them, answer questions as we go. Baby James is asleep. That's why we started at 8:15, because he goes to bed at 8. He's directly above my head right now. That's where his crib is. There's quite a bit of delay between when I say something and when it shows up on the stream, so if you do have questions, they'll come in probably 15-30 seconds after I say something, so I'll try and keep an eye on it and get those answered. Like the background, this is my house. This is where I live. Despite what you may have heard, I live in a house, not at school. I would say this is my office, but calling it an office doesn't really seem right. This is the room where the computer is. Or you mean the desktop background? All right, it's 8:15. Let's get started. What would y'all prefer? Go ahead and tell me, would you rather I just talk through the problem top to bottom? Do you want me to introduce the problem and give you, a couple minutes to look at it on your own? Or do you just want to hear me run through it? What do you think? Promise we can't do WADA at 2 a.m. because you need 8 consecutive hours of sleep tonight before your exam. WADA at 2 a.m., that's summertime. One vote for talk through it, run through, talk. All right, here we go. I have not looked at the answers. I'm just kind of doing it live, so here we go. This is the 2008 AB number 4, so non-calculator. We've got let f be the function given by f of x equals natural log x times sine x. The figure above shows the graph of f from 0 to 2 pi. The function g is defined by g of x is the integral from 1 to x of f of t dt from 0 to 2 pi. So my thought process here is I'm already looking at this. I'm already very suspicious of this function. I think I'm going to take its derivative later. Using FTC2. And when I look at part A, I see find g of 1 and g prime of 1. So that's it. We're going to be taking a derivative here. So find g of 1, I'm just going to plug in. So g of 1 is going to be the integral from 1 to 1 of f of t dt. Okay, properties of definite integrals at the top and the bottom bound match. The value is 0, easy enough. Find g prime of 1. To find g prime of 1, we need g prime of x, so I'm going to take the derivative of this function, okay, using FTC2. So g prime of x is going to be, take the x, plug it in, so f of x times 1. So g prime of 1 equals f of 1. How am I going to find f of 1? I'm going to come up here and plug it into f of x. So natural log 1, 0 times sine 1 is, how about it, also 0. Lagrange error bound, or no, we'll see if we can fit that in. B, on what intervals, if any, is g increasing? Justify your answer. So I know that g is increasing when g prime is positive. And I know from earlier that g prime is the same as f of x. So I just need to know where is f of x positive. So I'm looking at my graph of f of x right here. I'm looking at that area. And that's it. Hi, Amit. This is free to the public. Just doing it for the whole world, all 23 of you. So here's a question. Like, what is this root right here? I used to give this in an in-class test, and people would say 1 to 3. But that's not 3. This function is natural log x times sine x. So think about, when would either one of those be 0? Natural log x is 0 when x is 1. Sine x is 0 at 0 and every multiple of pi. So that point right there is pi. So the answer to part B is g is increasing on the interval from 1 to pi. Justify your answer. Why is that true? Because g prime is positive. C, from 0 to 2 pi, find the value of x at which g has an absolute minimum. Okay, I see this word absolute minimum. My mind goes to the candidates test. So I need to find all critical values, the endpoints, and plug them all in. So, okay, where is g prime? I need to find my critical values. Where is g prime equal to 0? Okay, I'm seeing that happening at 1, at pi, and at my endpoints. Of those two critical points, which one is a minimum? That's going to be when your derivative crosses from negative to positive. So I see that happening at 1. So I don't need to check pi, because I know that at pi, this is a relative maximum, because I'm changing from positive to negative. So when I do my candidates test, I've got values of x, values of g of x. I need to check my endpoints, 0 and 2 pi. And I need to check the one critical point in between that is a minimum. So that's going to be at 1. So g of 0, that's going to be the integral from 1 to 0 of f of t dt. Do we need to find the exact value? I mean, we have a graph here, so let's just kind of look. Is my mouse going to show up here? I don't know that it will, so I'll do this. So the integral from 1 to 0, I really want to flip those bounds and make it the integral from 0 to 1, but the result is that I'm going to have to make it negative. So I've got negative area here from 0 to 1, but I need to flip it and make it positive. So I know that g of 0 is a positive number. G of 1, we found in part A, is 0. And g of 2 pi, that's the integral from 1 to 2 pi of f of t dt. That's going to be this entire area right here, which is a great big negative area. So my candidates test shows me that I've got 3 candidates, only one of them is negative, so the absolute minimum, the value of x where it has an absolute minimum, is at 2 pi. As far as justification goes on that, if you are doing the candidates test, like if you have everything there, which is finding your critical values, checking all of your candidates in a table, then you can pretty much just state by candidates test the absolute minimum occurs at 2 pi. Okay, and if you have all the work for candidates test shown, that's a good justification. And from 0 to 2 pi, is there a value of x at which the graph of g is tangent to the x-axis? I think this is worded a little bit confusingly. I remember when I taught this problem before, when they say tangent to the x-axis, they're talking about this picture right here, where sort of bounces off the x-axis, that is a point where g of x equals 0 and g prime of x equals 0, which is convenient because in part A we already found that. In part A we already found that when x equals 1, g of 1 is 0 and g prime of 1 is 0. So the graph of g, which by the way we don't know what the graph of g looks like, but the graph of g is tangent to the x-axis at x equals 1. So that's number 4. We had FTC2. We had relationships between f, f prime, f double prime, or in this case g, g prime, g double prime. We had candidates test. And I'll give the stream a second to catch up. Any questions on 4 before we move on? Hooey dang, can I get a shout out? Yeah, man, whoever you are, glad you're here. All right, let's keep moving. Part B, quick question on part B. They said, where is g increasing? Okay, that all hinges on this right here, that g is increasing when g prime is positive. Okay, and we know, because of FTC2, that g prime is equal to f of x. So since we have a graph of f of x here, I want to know where f of x is positive. That is from 1 to pi. As long as you've already established this, that g prime of x is f of x, which you had to do in part A, then all the work you need is pretty much shown there. You're going to say g is increasing from 1 to pi because g prime is positive. All right, number 5, slope field. Fan favorite. Consider the differential equation dy dx equals x over y, where y is not equal to 0. A, the slope field for the given differential equation is shown below. Sketch the solution curve that passes through the point 3, negative 1, and sketch the solution curve that passes through the point 1, comma 2. So, 3, comma negative 1, that point is right here. Okay, and with slope fields, you just have to ride the wave. Okay, just go incrementally. Virginia, this is 2008 AB. And it is released, but I'm not sure how you find it. Google 2008 AB exam if you want to see it. So as I sort of move upward from this point, I can see that the slopes are sort of flattening out. And then if I continue to sort of ride along the wave here, I'm going to go that way. Similarly, as I move down from this point, I can see the slopes are sort of tending in that direction. So there's one solution curve. The other one, the one going through this point, 1, comma 2, again, just ride the wave here. I can see I've got what looks like a slant asymptote there I'm going to stick to. And moving to the left, I can see that I need to flatten out and then start to increase. Okay, slope fields on the AP exam are not an exact science. They are looking to see that you have it basically down. And so, you know, this is not a work of art by any means, but it's probably enough to earn full credit. B says, write an equation for the line tangent to the curve that passes through the point 1, comma 2. So, equation of a tangent line, if you're in my class, hopefully you immediately think to yourself, I need a point, I need a slope. Point, already got it. Slope, how do I get the slope? I'm going to take this point and plug it in a differential equation for dy dx. So my slope at this point, dy dx, equals x over y, 1 over 2. So the equation of the tangent line, just point slope form. Y minus 2 equals 1/2 x minus 1. Don't simplify that. Point slope form, box and run. Leave it as is. C, find a particular solution. Oh, yikes, I'm going to need some room here. Okay, when I see these words, find a particular solution, I know I need to solve this differential equation. How many ways do we know to solve the differential equation? 1. And that is to separate your variables. So Find a particular solution to the differential equation with the initial condition f of 3 equals -1. Here's my initial condition. I'm going to need that to solve for c later. So here we go. I need to get all my y's on the left, all my x's on the right. So I'm going to multiply both sides by y, multiply both sides by dx, giving me y dy equals x dx. Anti-differentiate both sides. 1/2 y squared equals 1/2 x squared plus c. Remember, you only need 1 plus c when you do a separable differential equation. And they did say y equals f of x. It means they want you to get y by itself. So I have options. I can get y by itself first, and then solve for c. Or I can go ahead and solve for c, then get y by itself. Recently, I've been a fan of just go ahead and solve for c. And the way the AP exam is scored, you get a point for solving for c, so we might as well just get that out of the way, because if we make a mistake after that, we don't want to lose our point for getting plus c. So let's just take care of that. We're going to plug in 3 for x, -1 for y, to get 1/2 equals 1/2 times 3 squared, so we'll call that 9/2 plus c. Let's see, 9/2 minus 8/2 would be 1/2, so c equals -4. So now I'm here, 1/2 y squared equals 1/2 x squared minus 4, and I need to get y by itself. So I think I will multiply everything by 2, y squared equals x squared minus 8, and square root. So y equals the square root of x squared minus 8. One interesting thing that this problem has that you don't see a whole lot of is it said state its domain. So like, what is the domain for this solution curve? This happens to be the one that we already drew. It's this one right here. So the domain, it's a sideways parabola, right? So it's going to be every x value from this vertex going to the right. So this solution is valid for values of x that are greater than or equal to, let's think about where that vertex would be when x is 0. Sorry, when y is 0, you would get square root of 8. So that's a slope field, equation of a tangent line, and separable differential equation. I'll say this, separable differential equations are almost always tested on the free response. I used to say they were always tested on the free response until Calc BC didn't have one last year. So Calc AB, you're still on a streak of these problems. Calc BC, my gut says is going to come back, but that is just a gut feeling and nothing else. So solution curves on a slope field should be pretty easy, just ride the wave. And separable differential equations, just remember there's only one way to solve a differential equation in calculus AB or BC, and that is to separate. Okay, 6. Okay, last one for this test. I'm going to do non-calculator because most of us don't have a calculator at home. And then we'll go look at the BC problems from this same year, which if you're in AB, you'll still understand probably about half of the BC problems because they're all rooted in AB topics usually. So, number 6, let g of x equal x e to the negative x plus b e to the negative x, where b is a positive constant. So one thing I want to do, I see negative exponents, and this might feel a little bit like cheating, but I kind of know that I want to rewrite this. This is x over e to the x plus b over e to the x. Why is it helpful to do this? Because I can see I have a common denominator. So this is just x plus b over e to the x. Now, why did they not give it to you that way? Probably because they want to confuse you. Alvin, I honestly don't have a plan. I don't know how long it's going to last. We're just going to write it out until either I fall asleep or people leave. 24-hour stream leading up to the exam. Dang, that's a thought, Joshan. We might do that. All right. So A says final limit as x goes to infinity of g of x. So I've got, let's write this guy down here. limit as x goes to infinity of x plus b over e to the x. If you're in my class, you're thinking Bobobotno ESDC. If you have a different teacher, you're thinking relative growth rates. The idea is the same. The denominator, e to the x, grows faster than the numerator, which is linear. So this value of this limit is 0. B, for what positive value of b does g have an absolute maximum at x equals 2/3? Justify your answer. So we want to have a maximum value at 2/3. This message is held for review, Nick Vu. I'm showing that. Here we go. So, to find a maximum, I need to find my critical value. So I'm going to take a derivative and set it equal to 0. Let's think about this. What's the easiest way to take a derivative of this function? Do I want to take its derivative in the form it was given to me? Or do I want to take a derivative in the simplified form that I found? When I look at the way it was written originally in the problem, I see product rule with some chain rule. When I look at the way that I wrote it, it's quotient rule. So what's the lesser of two evils here? I think I'm going to go for the quotient rule option. So g prime of x equals the derivative of the top, which is 1 times the bottom, e to the x, minus x plus b times e to the x over e to the x squared. And quick note, e to the x squared, power to a power. I can write that as e to the 2x. Okay. And to clean this up a little bit more even, I've got e to the x times 1 minus x minus b over e to the 2x. So, how do I find critical points? I want either the numerator or the denominator to be equal to 0. Okay, I should point out e to the 2x can never be equal to 0. E to the x can never be equal to 0. And so I am taking this and setting this equal to 0. And so if you think about it, they're saying, how does it have a maximum when x is 2/3? So I'm thinking to myself, if x equals 2/3, 1 minus 2/3 minus b has to equal 0. 1 minus 2/3 is 1/3. So b equals 1/3. It's the only critical value, as you can see. It's the only critical value that this has. And so you could verify with a sign chart, but I think it's enough to say this is the only critical value, and this is increasing up to that point and decreasing after. So it is the absolute maximum. C says, find all values of b of any for which the graph of g has a point of inflection on the interval from 0 to infinity. Justify your answer. So if we're looking for a point of inflection, we want f double prime to change signs. So let's think, how do I want to do this? If I take g prime of x that I just solved for, again, I'm just going in blind here, so you kind of get to see my thought process. E to the x over e to the 2x simplifies, leaving me with e to the x on bottom, and I've got 1 minus x minus b on top. So I think I'll take a derivative of this, again, using the quotient rule. So g double prime would be the derivative of the top, which is negative 1 times the bottom, e to the x, minus the top, 1 minus x minus b, times the derivative of the bottom, e to the x, over e to the x squared, so e to the 2x. And again, just like I did in part B, I'm going to factor out an e to the x on top. So after factoring out an e to the x in the numerator, I'm left with negative 1 minus 1 plus x plus b. I'm also distributing the negative there over e to the 2x. So that's negative 1 minus 1, negative 2 plus x plus b over e to the x. How do I get a point of inflection? I want to find a critical value, so either the top or the bottom equaling 0, and then changing sign. The bottom can't equal 0. E to the x can't equal 0. It's always positive. The top, negative 2 plus x plus b. Let's think about this. So I want negative 2 plus x plus b to equal 0. So my gut says it would depend on the value of x. Rather than deliberate, let's just jump down here and check. Okay, so here's the key. This is the derivative that we got, x, negative 2 plus x plus b over e to the x. This says if b is between 0 and 2, then g double prime will change sign at that value. Therefore, the graph of g will have a point of inflection when b is between 0 and 2. Okay, I get it. So they wanted an interval for b, not a value of b. So if b is between 0 and 2, then g double prime will change sign. So we'll hop back up to that one. We hold the e to the 4x on the bottom. So remember what happened there was I canceled the e to the x on top with the e to the x squared on the bottom. That's why that didn't happen. Okay, so I misread C. I just want to point out, kind of giving you my train of thought here. I thought it said find the value of b. So I got to this step here, and I'm going, how am I going to find just one value of b if I don't know what x is? Reading the problem more carefully, it says find all values of b. So that opens the door for this being an interval. Brian, baby James is asleep right now. Sorry. He's got to get 8 hours. I'm telling you, y'all need 8 hours of sleep. He's taking the test tomorrow. He's taking the BC exam. He's the only 1-year-old in the nation who's taking it. I think he's ready. Alright, let's jump to the 2008 BC exam. Let's see, this problem was common. I saw Nick asked about polar earlier. Let me take a quick look at these calculator problems. Number 1 was rate in, rate out. Number 2 was parametric. Just a quick look at this. They gave you dx dt and dy dt and then asked for speed. Okay, formula chart, square root of dx dt squared plus dy dt squared, plug in 3. Your calculator's going to do the heavy lifting there. B, write the equation for the tangent line. Okay, you got to find dy dx, dy dt over dx dt, plug in 3. There's nothing too spicy there. Describe the behavior of the path as t increases without bound. This increases without bound. They're just saying take a limit as t goes to infinity there. Oh, Brian, you might have heard something. Might have been the baby crying or the cat crying. The cat's very upset that she's not in here with me right now. All right. So this problem is similar between the AB and the BC exam, so we worked this one to start the stream. So let's dive down here and look at number 5. I need to make some room for myself here. Number 5 says, let f be the function satisfying f prime of x equals 4x minus 2x f of x for all real numbers with f of 0 equals 5. Initial condition, I'm already recognizing that. And the limit as x goes to infinity of f of x equals 2. Whew, this seems hard. Again, I'm looking at this for the first time, so you can kind of see my thought process here. So if I make a mistake, then that'll be fun to watch. A, find the value of the integral from 0 to infinity of 4x minus 2x f of x dx. Show the work that leads to your answer. So my gut reaction here is I'm going to split this into 2 improper integrals. And then 4x, that is going to be simple enough. The integral from 0 to infinity of 4x is infinity. That diverges. So you got something that diverges minus who cares. So I'm already thinking maybe I don't have to do the second integral. I really wonder about that because I was going to think integration by parts for that. So here's my thought process. Okay, this is free response. I got to show my work nicely. So part A, I'm going to say the limit as b goes to infinity of the integral from 0 to b of 4x dx minus the integral from 0 to b of 2x f of x dx. And I'm going to kind of follow my gut here. I'm going to work out the first integral. So I've got the limit as b goes to infinity of 2x squared evaluated from 0 to b equals the limit as b goes to infinity of 2b squared minus 0, which equals infinity, which diverges. So, we might come back and fix this if I was wrong, but my gut here says, therefore, the entire integral must diverge. The integral from 0 to infinity of 4x minus 2x f of x diverges. Maybe there's some trickery that I'm not seeing there, but sure seems like you've got something that diverges minus who cares. Alvin, snipping tool won't work because this is on the iPad, not my PC. B, use Euler's method to approximate f of -1, starting at 0 with 2 steps of equal size. So for me, I gotta say I'm pretty thrilled when I see Euler's method on a free response. That's kind of a gimme. I'm starting at 0, going to -1 using 2 steps. So my step size, my delta x, is going to be -0.5. And some teachers teach a table method for Euler's method. I'm a fan of just repeating. So here's how I would do this. I would say f of 0 is 5. F of -0.5 is approximately f of 0 plus f prime of 0 times -0.5. Okay. F of 0, they gave me that initial condition up here, is 5, so equals 5 plus f prime of 0. How am I going to get f prime of 0? Okay, I've got my function for f prime of x up here. So f prime of 0 would be 0 minus 0. Great. So 0 times -0.5 equals 5. F of -1 would be approximately f of -0.5 plus f prime of -0.5 times -0.5, which is going to be f of -0.5 we just approximated to be 5 plus f prime of -0.5 would be 4 times -0.5, so -2 minus 2 times -0.5, so make that a plus 1 f of -0.5. So -2 plus 5 is 3. So 5 plus 3 times -0.5, 5 minus 3 over 2 would be 7 over 2. Okay, so that one was a little bit tricky on the f prime. I think it's interesting that f prime referenced f of x. You don't see that very much, but it all kind of works within the Euler's method. So as long as you make that realization that when they say f of 0.5, we're going to use the approximation that we already found in the Euler's method. And C, find a particular solution. So Calc AB, friends, you are back in the fold now because this is a separable differential equation. To the differential equation, dy dx equals 4x minus 2xy with initial condition f of 0 equals 5. So I'm gonna find some room here. Let's see. Copy that. Bring it down here. Close enough. White out whatever you don't understand on the test. That's a valid strategy. Alright. So to solve this differential equation, I need to separate, of course. So let me think for a moment about how I'm going to do that. I think I'm going to factor out 2x. So I'm going to say this is equal to 2x times 2 minus y. Right. The reason why I have to do that is because I have to get all my x's, excuse me, all my y's on the left-hand side, all my x's on the right-hand side. This allows me to do that. So I can now say 1 over 2 minus y dy equals 2x dx. How do you write out that L'Hopital's rule applies in a free response question? You got to show two limits. Okay, do not write equals 0 over 0. Okay, they've made that clear. They don't want to see equals 0 over 0. If you get equals 0 over 0, scratch it out, start over. You got to show the limit of the top is 0, the limit of the bottom is 0. Two separate limits, 0 over 0, well, 0 and 0, or infinity and infinity. Then you can say L'Hopital's rule applies. But you've got to show two limits, or else, as I understand it, they're just going to say, sorry, too bad. So back to part C, I have separated. I have to integrate. Okay, I want to warn you here, there's a very common error on this left-hand side, the antiderivative of 1 over 2 minus y. If I were to make a common mistake, I would put this, natural log absolute value 2 minus y. Take a second, ask yourself what's wrong with that. There was a sort of a hidden u-sub here, or a hidden chain rule. Because the derivative of 2 minus y is negative 1, this antiderivative needs a negative in front. So negative natural log 2 minus y equals x squared plus c. Kind of like we discussed earlier, when you solve for c, I'm kind of the mind that we do it early rather than late. So let's just go ahead and take care of that. F of 0 is 5. So if I plug in 5 for y and 0 for x, I get something that looks like this. Negative natural log of the absolute value of 2 minus 5, so 3, equals c. So negative natural log absolute value 2 minus y equals x squared minus natural log 3. And geez, I hope they didn't say find y equals f of x. They did. So I'm going to get y by itself. So how am I going to get y by itself? I guess I'm going to get rid of the negative sign. So natural log absolute value 2 minus y equals, let's call it natural log 3 minus x squared. E both sides, that is not the mathematical way to say that, but it's how I say it. Make both sides a power of e, giving me 2 minus y equals e to the natural log 3 minus x squared. Anytime you have a natural log in the exponent of an e, you should be suspicious. This is no different. How about this? E to the natural log 3 times e to the negative x squared. That's legal. E to the natural log 3 is just 3. That's legal. 3e to the negative x squared. And I'm almost there. I just need to get y by itself. So y equals 2 minus 3e to the negative x squared. Okay. That's a long problem. There was a lot going on there. I'm curious if I was right on part A. I'm still very sort of suspicious that I might have been a little hasty and made a mistake there, because I never used this information right here. That as x goes to infinity, f of x equals 2, so we'll go check that. See if I made a mistake. Euler's method, okay, if you're in BC, we're happy to see Euler's method. This should be pretty easy. Separable differential equation, okay, if you see find the particular solution, hopefully you are equipped for that. Okay, separate, integrate, solve for c, solve for y. Nick, when you multiply exponents with the same base, you add them. Yes. This one really had it all for you, Nick. It had exponent rules and absolute value, square rooted. Man. Let's pop down to the answer in number 5 real quick and see. I have a very sneaky feeling that I might have fallen into a trap on part A. Yep, I did. Let's take a look. Oh, and I see immediately what I missed now. So, okay, probably a little bit more discerning than I would have caught this, but this right here is the same as this right here. Okay, so what they were really saying was find the integral from 0 to infinity of f prime of x. Which would be, using FTC, basically, this is going to be bad math, but I'm going to write it anyway, f of infinity minus f of 0, which f of infinity, okay, air quotes, we know is 2, f of 0 we know is 5, 2 minus 5 is -3. So I like that. I went at it from a completely different angle and fell into that trap, but that's what happens sometimes. So that's why I say it's hard even for me to make a perfect score on the AP exam. I can get every multiple choice problem right, but I would fall right into a trap like this. Because instead of looking at this and going, wow, that's hard, I wonder if they're going to help me, I just dive right in and try to go integration by parts on it. So that's pretty neat. You have to understand that those match each other. If they had written f prime of x there, it would have been a heck of a lot easier, but they're looking for you to recognize that. If you have any questions on that one, get them in, but I'm going to try and move on here. Let's see if I can do this without messing things up. Let's see. Trying to reset this page so I can work number 6 here. All right. Okay. All right. Cool. So you were asking about L'Hopital's rule earlier. This is going to be it. Alex, how often are sign charts going to be used on the AP exam? You can bet, or on the AB exam, you can bet at least one free response problem and a heck ton of calculator problems. They love to put those in the calculator section because it takes away your ability to use the calculator a lot of times. So the answer to your question, just real quick, on any sign chart problem, just make sure you know this relationship. If f double prime is positive, then f prime is increasing, then f is concave up, and if f prime is positive, then f is increasing. This to me encapsulates basically an entire chapter of the textbook, those relationships right there. So if you got that, or even if you can write that on a problem, then you can get those function relationship problems right. Number 6, the function g is continuous for all real numbers, and that's defined by cosine 2x minus 1 over x squared. A, use L'Hopital's rule to find the value of g of 0. Show the work that leads to your answer. Okay, so if I'm a calc student tomorrow on the test, here's how I would go about this. It's a limit. They said use L'Hopital's rule, but I need to verify that it does equal an indeterminate form. So if I go and I plug in 0, I'm going to get cosine 0 minus 1 is 0 over 0 squared is 0. Okay, so for me, I need that verification. I see I get an indeterminate form. Please don't leave this on your test. Okay, destroy the evidence. They do not want to see that. This does not equal 0 over 0. It equals something else. Okay, so let's just not leave it up to chance here. So I'm going to show two limits here. The limit as x goes to 0 of the top function, cosine 2x minus 1, equals 0. And the limit as x approaches 0 of x squared equals 0. Therefore, L'Hopital's rule applies. You can write LH, but hey, if you got the time, I would write it out. Back in the day, we used to get away with everything. We could write equals 0 over 0 and then just an arrow with an L on top, but those days are seemingly over. So, L'Hopital's rule applies. You can write like the original equation equals the next one, or you can just jump straight to the limit as x approaches 0 of the derivative of the top. So I've got the derivative of cosine 2x minus 1 using the chain rule, negative 2 sine 2x, over the derivative of the bottom, 2x. Okay. Oh, joy. Why do I say that? What's about to happen? When you plug in 0, 0 on top, 0 on bottom. So, can I write equals 0 over 0? I wish you wouldn't, because they're going to get you. Ah, mistakes were made. Okay. So, instead, I'm going to show two separate limits. The limit as x approaches 0 of negative 2 sine 2x equals 0, and the limit as x approaches 0, 2x equals 0. Therefore, L'Hopital's rule applies. And the fun continues. Got the limit. This is part A. Wow, this is a big part A. Limit as x approaches 0 of, the derivative of negative 2 sine 2x would be negative 4 cosine 2x over 2. And when I go to plug in 0 now, I get negative 4 times cosine of 0. So negative 4 times 1 is negative 4 over 2 is negative 2. So g of 0 equals negative 2. Alvin, do they count off for spelling? No. Yeah, what Nick said. As long as you're close. Okay. B and C are going to be BC only. So AB friends, now's your chance to get a drink. B, let f be the function given by f of x equals cosine 2x. Write the first 4 terms then and the general term of the Taylor series for f about 0. So what we've got here is we know the Taylor series for cosine x, or we should, okay, alternating even powers, even factorials. But instead of x, we're going to plug in 2x. So look, my advice, if you got time, I understand this is number 6, but if you got time, write out cosine first. Cosine x equals x to the 0, so 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus dot 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 plus negative 1 to the n x to the 2n over 2n factorial. That is 4 terms and a general term right there. And what makes it nice is now when I want to find cosine 2x, this is a simple substitution. 1 minus oh, hey, they asked for 3 non-zero terms. No, they didn't. I'm a liar. I'm looking at the wrong part. 4 non-zero terms. So, I'm trying to decide how much I want to simplify, and if I don't simplify, it might bite me on the next part. They did ask for 4 terms, so, you know what? I'll simplify if I need to later. So, 1 minus 2x squared over 2 factorial plus 2x to the 4th over 4 factorial minus 2x to the 6th over 6 factorial plus dot 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 plus negative 1 to the n times 2x to the 2n over 2n factorial. Keep in mind, they asked for a general term. If you put a sigma in front, it's no longer a general term. This is kind of what they want to see if they ask for a certain number of terms and a general term, something like this, an infinitely long sum with a general term embedded in it. So that would be part B. Part C then says, use your answer from B to write the first 3 non-zero terms in the general term of the Taylor series for G. So G of x is cosine 2x, which we just found, minus 1 divided by x squared. So I think I'm going to do cosine 2x minus 1 first. Cosine 2x minus 1 would just be equal to those would be your first 3 terms right there, right? Because the only thing that changes is that the 1 in front gets subtracted off. Now then, the Taylor series, you need to memorize e to the x sine x cosine x, and then bonus, I want you to memorize 1 over 1 minus x. And so then, when you divide that by x squared, it just means every term is going to be divided by x squared. So the first 3 non-zero terms are going to look like this. 2x squared over 2 factorial times x squared plus, that should have a negative in front, 2x to the 4th over 4 factorial times x squared minus 2x to the 6th over 6 factorial times x squared plus dot dot dot. They do want a general term, so I'm thinking negative 1 to the n times 2x to the 2n over 2n factorial times x squared. Okay, trying to keep it simple. The only difference with the minus 1 is where your n starts at. N isn't starting at 0, it's starting at 1, but that's fine. The general term still holds up. And finally, determine whether G has a relative min, max, or neither at 0. So that seemed like a scary proposition, but the idea is if you take the derivative of this whole thing and plug in 0, do you get 0? Okay, and then if so, do you get, a min, a max, or neither? So I'm out of space. So let's just jump down here and take a peek. Okay, part A was L'Hopital's rule. They gave you 2 points for that. Wow, look at this. Back in 2008, you could get away with so much. Look, they're not showing separate limits or nothing. Those were the days, man. Part B. Cosine 2x. Okay, they simplified, but the rules state you don't need to, so that's okay. 3 points for that. Part C, 2 points for that. And then D, so what they're doing is they're taking the derivative, G prime, showing that G prime of 0 is 0, and then taking one more derivative and showing that G double prime is positive. So this is what we call the second derivative test. Problem is, I don't know if it'll be safe for playback later, because I'm not sure I know how to do that. So we will see. Like I said, 30 minutes before this started, I was absolutely sure it was not going to work. So you've got a critical point that's concave up. So if you have a critical point and it's concave up, it has to be a minimum. It has to look like a cup. If it's concave down, it has to be a maximum. So by second derivative test, there is a minimum right there. All right. So what's our uptime here? 9:07. So it's been about an hour. We've done the non-calculator problems from both AB and BC from the 2008 test. Oh, dang, I can make mods? Man. All right, who made an A last semester? So let's do this. Let's look at 2012. Let's kind of cherry pick the ones that we want to look at or talk about. And then I'll call it right there. because I want you guys to get to bed and get a good night's sleep. I know everybody wants that full 8 hours. I know Logan needs a full 8 hours of sleep before tomorrow, so just like every night. Maybe he's already asleep. I don't know. So, let's see. 2012 AB exam. Lagrange, Romello, I hear you. We will find some Lagrange, my man. Let's just jump down here and see if there is some. I'm telling you, Lagrange is not as scary as you think it is. It's just the next degree term. Just like alternating series error bound, it's just the next neglected term. Yeah, this year's test had alternating series error, but I'll see if I can go find it for you after we look at this. So, we want the cat. Can y'all hear the cat? She's very upset that she's not in here with me. Polar. Okay, we'll see if there's polar on the BC exam. Yeah, I'm going to go more quickly on this test. We'll do more of a talk through than a work through, just so we can get more bang for our buck here. Formula sheet tier list. Page 1 is tier 1. Page 2 and 3 are tier 1.5. Okay, so look at this. I got 2012 AB, so this applies to everybody that's in here right now. 2012 AB. Got a table. Temperature of water in a tub is given by W. So W is temperature. Young James. Use the data in the table to approximate W prime of 12. So that's just using slope formula between 9 and 15. Not too bad. B, evaluate the integral from 0 to 20 at W prime. That's FTC1 because it's going to be W20 minus W0. Those values are given in the table. If you integrate a rate, remember that gives you an amount. So that's going to be the net change in temperature. C, they give you an average temperature. Use a left Riemann sum to approximate that. I'm just going to tell you right now, anytime they combine average value and Riemann sums, most people forget the fraction in front. They just dive straight into the Riemann sum, and then the 1/20th just disappears forever. So be aware of that. And then part D, they give you a different W prime and ask for the temperature. That's just FTC with an initial condition. Number 2. Let R be the region in the first quadrant bounded by the x-axis, and the graphs of ln x and 5 minus x is shown below. Find the area of R. So what's problematic about finding this area is the fact that the function you are integrating to changes right here. And the question is, what is this x value? So you're going to need to set these equal to each other, use your calculator, store that value. You're going to integrate ln x from 1 to that x value, whatever it is, and then integrate 5 minus x from that x value to, I guess this is 5, right here. And your calculator can do the heavy lifting there. Marco, I have a teeny tiny yard, man. A dog would not be happy here. B, region R is the base of a solid. Each cross-section perpendicular to the x-axis is a square. If you're in my class, you're thinking sad x, integral area dx. So write but do not evaluate an expression involving one or more integrals to give us the volume of the solid. So this is sad x, but just like in part A, you need to break it up at this x value right here. So you're going to do integral area dx from 1 to the intersection, and then plus integral area dx from the intersection to 5. So that's a little bit sneaky. C, the horizontal line divides R into 2 regions of equal area, right, but do not solve an equation involving one or more integrals whose solution gives the value of k. That's pretty sneaky because you've been working this problem from a dx perspective, and at the very end they're going to flip it on its head and make it a dy problem. You're going to write both of these curves in terms of in terms of y, and then do top minus bottom to find that k that splits it in half. That's a tough part C. Okay, on to the no calculator section. Okay, Alex, this is what you were asking about. Here's your sign chart problem, I guess you would call it. They're going to give you the graph of f, and then they're going to tell you g of x is the integral. That's not a highlighter. G of x is the integral from 1 to x of f of t dt. So when you see that, you're immediately thinking g prime of x equals f of x, and this is where all the sign chart business comes into play. So A, find the values of g of 2 and g of negative 2. Man, this is so similar to the problem we did in class today. Make a 5-question practice quiz with Polar, Taylor, etc. for Twitter. I don't know. Maybe. We can always just fly through the multiple choice here and just pick some problems out if we can't find any here. B, find g prime of 3 and g double prime of negative 3. Find the value or state that it does not exist. I can guarantee you the cusp is going to come into play here. Looking for horizontal tangent lines. This is all, I mean, if you've worked enough of these problems, then this all should feel very, very samey to you, because these problems are all kind of the same. Not much that's too noteworthy there. Number 4, f is defined by y equals the square root of 25 minus x squared. I don't know if it matters. I don't know if you need to know this, but that is a semicircle from 5 to negative 5. Find f prime of x. Okay, that's going to be chain rule. B, write the equation of the tangent line. You need a point and a slope. How do you get the point? Plug negative 3 into your function. How do you get the slope? Plug negative 3 into your derivative, and point slope function. Oh, baby, that's a piecewise function. That's your favorite right there. Let g be the function defined by g of x equals f of x. That's this guy up here. From negative 5 to negative 3, and then x plus 7 from negative 3 to 5. They want to know, is it continuous? All right, formula chart. If you're in my class, what's the definition of continuity? Got to hit 3 things. They're using negative 3, so we're going to say f of negative 3 exists, the limit as x approaches negative 3 exists, and they are equal to each other. So, does f of negative 3 exist? Or I guess in this case, g. Does g of negative 3 exist? Yeah, right there. Okay. It's defined at negative 3. Does the limit exist? Well, you need to know, if you plug negative 3 into this, and you plug negative 3 into this, do you get the same thing? If so, great. And then, are they equal to each other? Which, because this is defined as this endpoint, they should be. If they do match up, then they will be equal to each other. And then find the value of the integral from 0 to 5 of the x times the square root of 25 minus x squared dx. Let's stop down on this one, just because I think it's worth practicing a U-sub. It's pretty much a critical skill, so let's take a moment and do this one. Mr. Singh, this is AB right now. We're headed to BC next. So it's a U-sub. How do I know it's a U-sub? I see the 25 minus x squared inside the square root of the x outside, so u equals 25 minus x squared. du equals negative 2x dx. I don't have a negative 2x dx, so negative 1/2 du equals x dx. What else do I have to change? It's a definite integral, so I need to change my bounds, 0 and 5. How do I change these? I'm plugging 0 and 5 into this formula right here. So 25 minus 0 squared is 25. 25 minus 5 squared is 0. So my brand new problem is negative 1/2 integral from 25 to 0 of the square root of u du. Yeah, no calculator on this one. So I don't really like the 25 and the 0 where they are. I want to take those bounds and switch them. The consequence of that action is this becomes negated. So I've got 1/2 integral 0 to 25 of u to the 1/2 du. Remember, this is a definite integral. Okay, I don't need to put my x's back in ever again. I'm going to be u's all the way. I'm going to get a number for my answer, so I don't need to worry about putting x's back into my problem. It's been substituted. This is my new problem. So the antiderivative of u to the 1/2 goes up to 3/2, divided by 3/2, so I've got 1/2 times 2/3 u to the 3/2, evaluated from 0 to 25. So that's going to be 1/3 times 25 to the 3/2 minus 0 to the 3/2. 25 to the 3/2, let's square root it first to get 5 and then cube it to get 125. So I've got 125 over 3. Hey, Jacob. Yeah, we're doing both. We're just on AB right now. We're going to try and find some polar and a Lagrange error bound question later. 5, I'm just talking through it. This is the AB test, right? Okay. I thought this was logistic for a second, but it's not. The rate at which a baby bird gains weight is proportional to the difference between its adult weight and its current weight. They give you a differential equation. And oh, by the way, up here was an initial condition. So let's make a note. At time 0, the baby weighs 20 grams. Is the bird gaining weight faster when it weighs 40 or when it weighs 70? So you're going to take 40 and 70, plug them into the differential equation, and find which one has a higher rate. B, find the second derivative. Use the second derivative to explain why the graph of B cannot resemble the following graph. When you take the derivative of this, you're going to get, I'm trying to do it in my head, but I think it's going to be linear. But this will not look like this. If you're in BC, you look at this graph and you recognize that it's logistic with a carrying capacity of 100. You know what a logistic differential equation looks like, and it's not this because there is a missing B in front. So again, that's a BC topic, but if you saw this problem, that's what you're thinking, that this can't resemble this because it's not logistic. Use separation of variables to find a particular solution. Let's take a quick look at that. Just because it is such a prominent question type, it's going to be worth usually 5 points. So just quickly, I see people who try to do too much on this. Take the entire 100 minus b and divide it to the other side. So I've got 1 over 100 minus b db equals 1/5 dt. We talked about this earlier, but that antiderivative on the left-hand side has a hidden negative in it. Negative ln absolute value 100 minus b equals 1/5 t plus c. Okay. Use the initial condition to solve for c and then solve for b. Number 6, the velocity of a particle is given by v of t. When is the particle moving to the left? When is the particle moving to the left? In other words, when is velocity less than 0? Shouldn't be too bad. B, write but don't evaluate an integral expression that gives the total distance traveled. Again, if you're in my class, formula chart all day, every day. Integral, absolute value of velocity, dt. That's like the easiest point ever. C, find acceleration at time t. So you're going to take the derivative of the velocity. Is the speed increasing, decreasing, or neither? Alvin, why does it have a negative? That was the up here earlier. Sorry, I'm just now looking up and seeing that. Where does this negative come from? It's because the derivative of this denominator is -1. So if you did a u sub, which we never do a u sub on this, we just do it in our heads. But if you did a u sub, the derivative of the denominator is -1, and that -1 comes into play right there. Remember that if velocity and acceleration have the same sign, so if v of 4 and a of 4 have the same sign, it's speeding up. If they have different signs, it's slowing down. Neither. Why would it be neither? I guess if acceleration was 0. Find the position of the particle at time 4. So this is just an initial condition problem. You have this initial condition right here. So you're going to set up an integral from 0 to 4 of velocity. Plug in what you know, solve for what you don't. Okay, let's hop to BC. Oops, wrong one. Just kind of look at what we've got here. The BC exam in 2012 had the same water in a tub problem. That's going to be identical. Another parametric problem. I know we wanted polar, so I can try and find a polar for you, but this one is another parametric, which we talked about earlier. I'll see if there's anything that's out of the ordinary about it. They're going to give you, oh, I do want to mention this. At time 2, the particle is at position 1, 5. How many initial conditions is that? It's 2. They're giving you 2 pieces of information. X of 2 is 1, and Y of 2 is 5. I would go ahead and just write that down as 2 different initial conditions, just so it's in your head there. A is the horizontal movement to the left or to the right, so they want to know is dx dt positive or negative at time 2. Find the slope of the path of the particle, so dy dt over dx dt, plug into. B, find the x-coordinate of the particle's position at time 4, so that's a FTC1 problem, set up an integral, use the initial condition that we have from right here. C, find the speed of the particle, okay, straight formula chart stuff, the square root of dx dt squared plus dy dt squared, plug in 4. Find the acceleration vector of the particle at time 4. They said vector. This problem wasn't given to you as a vector. That does not really need to concern you. You're just going to take the derivative of this, plug in 4, derivative of this, plug in 4, and then stick some pointy brackets on either side of it. Again, this is number 2. This is with a calculator. So your calculator is going to do the integration for you. Your calculator is going to take the derivative of dx dt and dy dt and plug in 4 for you. Don't do anything by hand that the calculator can do for you. You want to save that time for later. And D, find the distance traveled by the particle from 2 to 4. Okay, remember, parametric distance traveled is the same thing as parametric arc length. Because if that's how far it traveled, finding this distance is the same as finding the length of that arc. So it's going to be the integral from 2 to 4 of the square root of dx dt squared plus dy dt squared dt. Okay, look how formula driven this problem was. You had to know, well, maybe not as bad as I thought. You definitely had to know the formula for speed and the formula for distance traveled. So, let's see, number 3, identical to what we talked about earlier. That was a shared problem. Number 4, this is new. Let's look and see what we got here. They give you a table with f prime of x. They give you these 2 pieces of information, f of 1 and f double prime of 1, and then ask you to find equation of a tangent line. Use this line to approximate 1.4. So people in my class, you can't just cheat this out with the linear approximation formula. You need to do both steps. Find the equation of the tangent line, then plug in 1.4. Okay, point, slope, easy enough. B, use a midpoint Riemann sum to find the value of the integral from 1 to 1.4. We don't do a lot of midpoint sums. The nice thing about midpoint sums is that they kind of have to give you a table that works with a midpoint sum. If you're going from 1 to 1.4 with 2 steps, these are your 2 rectangles, and you're not going to pick the right side, from your perspective, the right side, you're not going to pick the left side, you're going to pick the middle. So the height of these rectangles are 10 and 13 for a midpoint sum. C, Euler's method, okay? Yay, Euler's method. Get it, got it, good. D, write the second degree Taylor polynomial about x equals 1. So to do that, you're going to need to know f of 1, f prime of 1, f double prime of 1. How are we going to find those values? F of 1, f prime of 1, f double prime of 1. So they're all up there. You need to know the Taylor formula. Shoot, I'll go ahead and write it. So it's going to be f of 1 plus f prime of 1 times x minus 1 plus f double prime of 1 times x minus 1 squared over 2 factorial. So take those 3 values that you know from up above, plug it in, plug it in, plug it in. Then, when you've done all that, approximate f of 1.4. What I would do is replace the x's with 1.4s and box and run that thing. Okay, I'm not going to simplify. I don't have to. Number 5, we're back to the baby bird. Okay, great. So BC kids, you look at that and go, hey, this isn't going to be logistic. That's not a logistic differential equation. Separation of variables. And, all right, number 6. So I guess it's just a rule that every BC exam has to end with a series question. I've never seen a test that doesn't end with a series question. This one gives you a Maclaurin series, says use the ratio test to determine the interval of convergence. Usually the ratio test is worth 5 points. It's like a separable differential equation. Let's do a quick run through on this one. We'll do the ratio test, and then we'll go hunt down some polars and maybe a Lagrange if we can find one. Romello, I know you said Lagrange, but there's like maybe one problem per year that uses Lagrange. So we'll see what we can find on a released exam, because I don't want to show anything secure on the live stream. So number 6, use the ratio test. Okay, so how does the ratio test work? I'm going to take the limit as n goes to infinity of the n plus first term. So, oh, and by the way, absolute value kills the alternating part. So x to the 2 times n plus 1. So 2n plus 2 plus 1. So 2n plus 3. If that was super confusing to you, then I'll try and come back and explain it again in a little bit. Over, here, I'll do it right here, 2 times n plus 1 plus 3. So that's 2n plus 2 plus 3, 2n plus 1. Divided by the nth term, so I'm going to flip and multiply by the nth term, 2n plus 3 over x to the 2n plus 1. This is the limit that I'm evaluating. The nice thing about the ratio test is that stuff cancels every time. So, well, not every time. If it doesn't, though, you probably used the wrong test. Limit as n goes to infinity of, all right, how many x's do I have left over? Looks like I've got 2 more x's on top. So I've got x squared times 2n plus 3 over 2n plus 5. I don't want to belabor this point too much. This is what in my class we call EATS DC, the same relative growth rate, divide the leading coefficients, whatever you want to call it. This limit evaluates to x squared in absolute value. And for the ratio test to converge, I want this to be less than 1. This is one we can solve mentally. X squared in absolute value is less than 1 if x is between -1 and 1. Am I done? No. You've got to check your endpoints. That's part of the interval of convergence testing. So I'm going to take, let's change colors here. I'm going to take -1 and plug it in for x right there, and then see if this series converges or diverges. So at x equals -1. Jacob, I see your question about adding 2 to n. See if I explained it better in the denominator there. When x equals -1, here's my series. I've got the sum from 0 to infinity of -1 to the n times -1 to the 2n plus 1 over 2n plus 3. So let's clean this up a little bit. Okay, I've got the same base being multiplied here, -1 and -1, so I'm going to add the powers. So this is the sum from 0 to infinity of -1 to the 2 to the 2n plus 1 plus n, so 3n plus 1. Over 2n plus 3. So you may not recognize this. Does 3n plus 1 alternate? If you're not sure, you can plug in values. Like when you plug in 0, you get 1. When you plug in 1, you get 4. When you plug in 2, you get 7, and so on. So you can see it's going up by 3 each time, so it is alternating. So this is an alternating series. The denominator is linear. Okay, different teachers teach this stuff different ways, but for me, this is going to converge via the alternating series test, because the 1 over 2n plus 3 is decreasing to 0 and alternating. So this converges by the alternating series test. So I'm going to include -1 in my interval of convergence, and that was so much fun that I'm going to repeat the process when x equals 1. Yeah, Alvin, half the free response are shared, and usually about 5 multiple choice. When I plug in 1, I've got the sum from 0 to infinity of -1 to the n times 1 to the 2n plus 1 over 2n plus 3. 1 to the 2n plus 1 is just 1. Like, I can just get rid of that, and we're good. Again, I have an alternating series with terms that decrease to 0, so this also converges by the alternating series test. So I'm going to include 1. Both endpoints are included. Got my answer. Okay. That's time consuming, but it's probably 5 points, so it's worth knowing what to do. When you do the ratio test, you're going to get a lot of play with the alternating series test. For me, recognizing harmonic series or knowing how to use the limit comparison test will carry you a long way on the rest of that stuff. Part B, they said Maclaurin series at x equals 1/2 is an alternating series whose terms decrease in absolute value to 0. The approximation using the first 2 terms is 17 over 120. Show that this approximation differs by less than 1 over 200. So they're asking you to do the alternating series error bound. In other words, if you add together the first 2 terms, then the error, the amount that you miss by, is smaller than the 3rd term. So what they want you to do is go back to your series right here, plug in 1/2 for x. You can even plug it in here, here, and here, and figure out what that 3rd term would be. Let me pop back for a second here while I'm in the neighborhood and answer Jacob's question, why did we add 2? So I'm going to redo this first step of my ratio test. I want to take the n plus first term. So I'm going to take all the n's, so this one right here and this one right here, and replace it with n plus 1. So I've got x to the 2 times n plus 1 over 2 times n plus 1 plus 3. So this numerator becomes x to the 2n plus 2 plus 1, x to the 2n plus 3, and this denominator becomes 2n plus 2 plus 3, which is 2n plus 5. So it's because the n is being replaced by n plus 1, and it has a coefficient, so that's what's going on there. But on that alternating series error bound, here's your 3rd term, x to the 5th over 7. So you can say that the error in absolute value is less than or equal to 1/2 to the 5th over 7. 2 to the 5th power is 32, so that's 1 over 32 over 7, which is, shoot, I don't know, definitely too tired for this, 14 and 22. One over 224 and 1 over 224 is in fact less than 1 over 200. So the error is less than 1 over 224, which is less than 1 over 200. That's alternating series error bound. Romello, you asked about Lagrange. This is alternating, but hey, it's good to know both. Okay, let's do this. I don't want to go too much longer. We all need good sleep before the exam here. I'm going to jump back up to the multiple choice, and we're just going to do a run through. And let's just target specific skills. Okay, and y'all can help me make a list here. We want to look for polar problems. We want to look for any Lagrange problem we can find. Okay, is there any other topics that you want me to stop down and look at as I do a quick run through this multiple choice? And then we will call it quits, and go to sleep and wake up, and I'll get 5s. Okay, I got logistic growth. I'll look for a logistic growth problem if I see one. Polar Lagrange error. Okay. Alright, let's just run through. If I see anything interesting, I'll look at it. Number 1, chain rule. Number 2, when is the particle at rest? So when is the x velocity and the y velocity both 0? Number 3, just finding area on a graph. Number 4, arc length, just a formula. Number 5, Maclaurin series. They're saying find the value of f of 3. You're going to plug 3 in right there. It becomes a convergent geometric series. Use the formula a1 over 1 minus r. Number 6, u substitution where they hold your hand. That's nice. Number 7, implicit differentiation. Make sure you know the derivative of arc sine x. Eight, oil is being pumped into a tank. Use the right Riemann sum to approximate the amount of oil. So Riemann sum, pretty easy. 9, which of the series converge? Got a request for series questions, so let's look at this. Oh, number 1, 8 to the n over n factorial. That's going to be a ratio test. At least that's the first thing that jumps into my mind. I'm like 90% sure it's going to converge. Number 2, diverges by the nth term test because n factorial dominates n to the 100th. And number 3, my favorite test, limit comparison test. If I was going to do limit comparison on this, I would multiply by n squared over 1. And we know that 1 over n squared converges, so 3 converges. So for my money, I'm taking 1 and 3. Only spending 20 seconds on that. Number 10, do you know how to take an antiderivative? I hope so. Number 11, classic trick question. Do you know what this graph looks like? Most people don't. It's the square root graph, but it's got absolute value, so it also goes like that. Not differentiable at that point because of the cusp. 12, sneaky second derivative test problem. They want you to find the second derivative at both those points. Plug into the first derivative, figure out if it's a critical value, and then see if it's concave up or concave down. 13, radius of convergence of the series. As tempted as I always am to try and shortcut these, I would do the ratio test because you might as well get it right. So, quick and dirty ratio test, here we go. Limit as n goes to infinity of, Jacob, if you're still here, here's another 2n. So, x minus 4 to the 2n plus 2 over 3 to the n plus 1 times 3 to the n over x minus 4 to the 2n. What do I have? What do I have? I've got 2 extra x minus 4s on top, so x minus 4 squared, and 1 extra 3 on the bottom. There are no more n's, so the limit is done. And I want this to be less than 1. So I think I would make this x minus 4 squared, and absolute value is less than 3, square root both sides. So x minus 4 in absolute value is less than square root of 3. And there's your radius, square root of 3. Hey Jacob, the root test is not technically tested on the AP exam, so it's possible to have a problem where you could use the root test, but it's not technically a tested test, so a tested test. So ratio is going to be the plan there. Martin C., this is a Calc BC topic, so if you're in BC, then maybe your teacher didn't teach it to you. Sorry. 14, which of the following is logistic. Somebody asked for logistic. This is a great, I hesitate to call it a trick question, but I know lots of people are going to get tricked by it. So take a minute and ask yourself which one of these 5 is logistic. Okay, logistic differential equations, this is what I teach my students. dp dt equals kp times L minus P. That's the form that we're looking for. Your teacher might teach it differently. This is how I like it. What's interesting to note and what you need to remember is that these variables all need to match each other, and they are the dependent variable. So the trap answer, if you will, is C. C looks good at first, but these T's are the independent variable. The correct answer is E. All right, 15. This is an H prime, H double prime problem with FTC2 wrapped in. Zealous root test is not really relevant. It's not part of the College Board scope and sequence. Almost everybody teaches it because your college professor probably wants you to know the root test, but it's not going to be on the AP exam. Or if it is, it'll be something you can solve with the ratio test. All right, keep moving. Euler's method, POG 17. This power series converges to which of the following? So, let's look at the answer choices here. I like this problem, but it's one that can be difficult. Let's start with the easy ones. Is this cosine x? Cosine x it's alternating, has even powers of x, even factorials. This has even powers of x, odd factorials. So it's not cosine. It's not sine by the same logic, because sine has odd powers, odd factorials. Is it sine x over x? Sine x over x would be even powers, odd factorials, and alternating. Oh my gosh, it is. Hmm, 18. They're going to give you a graph of f prime and an initial condition. So I'm not going to work the whole thing, but this is a textbook FTC1 problem. Yash, Newton's law of cooling and work are not covered in the College Board scope and sequence, so it will not be on the test tomorrow, but your college professor will be happy that you know it. On this one, they're asking for -5. I know about 2. Integral from -5 to 2 of f prime of x is going to be f of 2 minus f of -5. Okay. This I know, this I can find out, and that's going to allow me to solve for that. 19, function f is defined by that. What points out the property that the line tangent to that has a slope of 1/2. They're just asking us to take the derivative, set equal 1/2. 20. 20, 20, 20. All right, hey, here's a BC problem. Take a look at this. Hang on one second, I'll be right back. What's going on here? Got 5x plus 8 over x squared plus 3x plus 2. It's not a U sub. So what's the next thing you try? Does that denominator factor? Yeah. I've got x, that's a highlighter. I've got x plus 1 times x plus 2 in the denominator. If that denominator factors, you can bet it's partial fraction decomposition. You got like one a year probably. Partial fractions, they're usually on the test. I beat this to death in my class. I hope your teacher has too. These should be pretty easy. Yeah, Ian, if this was long division, that would be a big skip. For most students, I like long division. You're in the 8th grade, so you'll be in calculus next year. 21, the line y equals 5 is a horizontal asymptote to the graph of which of the following functions? This is just a limit as x goes to infinity. They are trying to trick you with D. D is a trap answer here. Alvin, you can't use a calculator on a non-calculator problem, my guy. The correct answer is not D, it is E, because 20 over 4 is 5. 22, the power series converges at 5, which of the following must be true? Okay. What is the most prevalent BC topic that we should absolutely know? Series, everything series. One free response is guaranteed to be series. Problems like this are littered throughout the free response. Knowing your convergence tests is important, but just knowing about intervals of convergence and power series in general is most bang for your buck. You can bet there's going to be a free response over either polar or parametric, but I can't tell you which one because I don't know. So let's look at this one though. When you look at this power series, you can see where it is centered at. It has to be centered. This is x minus c, so it's centered at 3. Yeah, so there's the center of my interval of convergence. I don't know how wide it goes, but I know it converges at 5. So at 5, it converges. So what does that tell me? Well, 5 was 2 in that direction. So what's 2 in the other direction? That would be 1. Does it converge or diverge at 1? I don't know. Because 5 could be an endpoint. 5 could be an endpoint. And if it's an endpoint, then 1 would be an endpoint. So I don't know. So what I do know is that anything between 1 and 3 has to converge. So any number that's in this range right here, or this range right here, has to converge. So my answer choice is the series diverges at 0. I don't know. Maybe it goes even wider. B, the series diverges at 1. I don't know. Maybe it's an endpoint. C, the series converges at 1. I don't know. Maybe it's an endpoint. D, the series converges at 2. Yes. It definitely converges at 2 because the radius of convergence, R, is at least 3. So 2 falls in there. Yikes. I just navigated off this screen. Hopefully the stream stayed up. Uh, 23 is not logistic. They said which of the following differential equations describes linear growth. Remember, a linear equation has a constant derivative, so that's just A. 24, integration by parts. Good to know, but not the most important thing. Improper integrals, same thing. I mean, yeah, they're good. They're going to be tested, but not on the same level as series necessarily. Here we go. Slope of a line tangent to a polar curve. So people have been asking about polar. So slope of the tangent line is dy dx. How are you going to find dy dx for a polar problem? Hey, see you later, Logan. Say hi to Bailey for me. 5s tomorrow. All 5s. Let's go. Logan, 7:15, small gym tomorrow. Polar dy dx. There's a formula. You can memorize it if you want to, but it's the night before the exam. So if you don't have it memorized, this is not the time to go memorizing it. You should figure out how to solve it. So dy dx equals dy d theta over dx d theta, just like in parametric. But you got to remember y is r sine theta, x is r cosine theta, and to find those derivatives, you have to use the product rule. So the formula is this: r prime sine theta plus r cosine theta over r prime cosine theta minus r sine theta. But if you didn't have that memorized prior to today, don't try to memorize it now because you're going to screw it up. So once you've got that, once you know what r prime is, you start plugging everything in. Plug in theta equals 0, get your slope. Brandon, this was AB and BC, but it seems like most of the people that are still in here are BC students, so that's what I've been focusing on. 27, series problem. People who asked about series, here you go. For what value of p will 1 over n to the 2p and p over 2 to the n converge? Well, that's a p-series. It's going to converge if the exponent is bigger than 1. So I need 2p to be bigger than 1, which means p has to be bigger than 1/2. This is geometric. It's going to converge if p over 2 in absolute value is less than 1. So I need p in absolute value to be less than 2, so I need p to be between negative 2 and 2. So what value of p makes both of these true? You got to be bigger than 1/2 but smaller than 2. Bigger than 1/2 but smaller than 2. There we go. (28) I don't feel the need to work this, but take a quick look at it. It's a limit. When you see a limit on the AP exam, you should be very suspicious that it's L'Hopital's rule. And this one is. Because when you plug in 1, you get 0 on top, and you get 0 on bottom. So you should be aware of that. Alright, still going through looking for some of those interesting problems. Which of the following statements about f is false? It's not differentiable because that is a sharp turn. 77, where is the rate of change greater than the rate of change? The rate of change of f of x greater than the rate of change for g of x. So you're comparing f prime and g prime. If you get this problem wrong, it's because you don't plug it in your calculator correctly. 78, I just want to show you on this one what to do with this. They say, what's the value of that integral? You need to take that thing and break it apart. So you're going to have 3 times the integral from negative 1 to 9 of f of x dx plus the integral from negative 1 to 9 of 2 dx. This is just 20. So you need to find this area. So I've got 3 times something plus 20 equals my answer. Okay. Test taking strategy. Here's what I notice. A and C are 20 units apart. What's the most common mistake on this problem? Probably not adding the 20. So I would say the answer that's 20 units bigger is probably correct. So if you are completely lost tomorrow and you need to throw up a Hail Mary, that's a good strategy. Think about what's the most common mistake and try to reverse engineer the problem. 79. Okay, Taylor polynomial. Give you a second to stare at this one and think about how you would set it up. My hint is think about where it's centered. I'll give you a few seconds. Okay, why the 20 on this problem? Anytime you integrate a constant, integrating a constant is the same thing as finding the area of a rectangle. The height of the rectangle is 2, and the base of the rectangle goes from negative 1 to 9, which is a distance of 10. So 10 by 2, that area has an area of 20. So 79, it's a Taylor polynomial centered at 3. So I'm just going to write the formula. It's going to be f of 3 plus f prime of 3 times x minus 3 plus f double prime of 3 times x minus 3 squared over 2 factorial. They said third degree, so I guess I'm still going, plus f triple prime of 3 times x minus 3 cubed over 3 factorial. And now I can start plugging things in. F of 3 is 2 plus f prime of 3, so negative 1 x minus 3. So A is out, not centered at 3. B is out, not centered at 3. C, D, and E are all still in contention. Plus f double prime of 3, so I've got 6 over 2 times x minus 3 squared. So I'm looking for a 3 there. C is out. Plus f triple prime of 3, 12 over 3 factorial, which is 6. So I'm looking for a 2 there. E's my answer. Here's the graph of f prime. They're asking about relative mins, maxes, concavity, points of inflection. Easy peasy. Moving on. 81. If f of x equals f of negative x, all right, so they're being sneaky. What are they saying without really saying here? F of x equals f of negative x. means that this is what we call an even function. It's an even function. It's symmetric across the y-axis. Who's our most famous even function? I would say either x squared or cosine x. So what that means is that the whole left side of this table, from -1 to 0 and from -2 to -1, is going to mirror the other side. And so you're going to have, trying to remember what this one says. What are the points of inflection? So f double prime changes from negative to positive at 1, but it's also going to do so at -1. So Alvin, if we have time, we will, but we're already getting close to 10 o'clock, which is about the time I wanted to be done, so we might... You can talk to me about it in the morning, probably. Jacob's got a question I'm looking to see as he types it in here. When you take the derivative of a definite integral with one of the bounds as a variable. You're talking about the second fundamental theorem of calculus. So I'm just going to make an example while you type here. So I've got the integral from pi to 3x squared of sine t dt. And you want to take the derivative of this thing. They're asking what's the derivative with respect to x of this. The way the second fundamental theorem works is you take the function on top. It has to be an integral from a constant to a function. Take the function on top, plug it in. So I've got sine of 3x squared. And then multiply by the derivative of that upper bound, so times 6x. That's how those kinds of problems works. Make sure it's from a constant to a function. Okay, if it's from a function to a constant, flip it, but don't forget to make it negative. 82, average value. Don't forget the 1 over b minus a, the whole thing that makes it average value. Question about continuity. We can do that. Concavity. Okay. Here's an interesting one. I just want to ask, how would you solve this? They gave you f prime and then asked where is f concave down. A lot of students would want to take the derivative of this, graph the derivative, and find where f double prime is negative. That seems like a pain. I don't want to take the derivative of this function. I'd rather just graph this in my calculator. So f is concave down when f prime is what? Decreasing. So I would just graph that and see where it's decreasing is probably faster than taking its derivative. Not too interesting. 86, f prime is positive, so it has to be an increasing function, and the integral from 4 to 7 is 0. I do like this problem. If you have an increasing function and the integral from 4 to 7 is 0, what does that mean? It means from 4 to 7, my graph has to cross from negative into positive so that those areas will cancel out. Because if it's an increasing function, that's the only way to get an area of 0. So I'm looking for an answer choice that's increasing and goes from positive to negative. Increasing, I said that backwards. I'm looking for an answer choice that's increasing that goes from negative to positive. And B is that. It's the only one that's increasing and changes from negative to positive. C looks good, but it's not increasing. All right, we're in the home stretch. Non-circular cross sections. Not too bad. Which of the following could be the derivative of, or the graph of f? Not too bad. The particle's velocity is that. That's just an initial condition FTC1 problem. 90. Bye, Jacob. Good luck tomorrow. If the series converges and a sub n is positive, which of the following must be true? How about this? A strictly smaller series will also converge. Dividing by n makes it smaller. It already converges as is, so making it smaller, it's going to converge. Polar, we finally found one. So anybody's still here that wants a polar problem. Here we go. Figure above shows the graphs of the polar curves r equals 2 cosine 3 theta. That's your rows, and r equals 2. That's your circle. What's the sum of the areas of the shaded regions? So here's what I would tell my students with polar area. symmetry is your friend. Okay? Rather than setting up a convoluted integral to solve this, here's what I want to do. I want to find the area of 1/2 petal. I want to find the area of 1/2 petal because how many half petals make up this whole thing? 6. So I find the area of the circle, not hard, pi r squared, and then just subtract the area of the rows. So if this graph is 2 cosine 3 theta, I want to know when does 2 cosine 3 theta come back, because we know it starts here. When does it come back and hit the origin? So when is 2 cosine 3 theta equal to 0? That's going to happen when 3 theta is equal to pi over 2, so when theta is pi over 6. That's a bad theta. It's a shameful theta. There we go. So here's what we've got. A half petal is 1/2 integral 0 to pi over 6 of r squared, 2 cosine 3 theta squared. This is a calculator problem, so punch that in your calculator, get the area, multiply it by 6 to get the full rows, and then just subtract it from the area of the circle, which is pi r squared. Pi times 2 squared, 4 pi. So I got 4 pi minus 6 of that thing. That's going to be your answer. Okay, last one. H is differentiable. H of x equals h of 2 minus x. This is kind of a tough problem. You have to like plug in numbers to figure out what's going on, but they're basically telling you that this is symmetric across x equals 1. Because h of 0 equals h of 2. H of negative 1 equals h of 3. H of negative 2 equals h of 4, and so on. H of 1 equals h of 1. So using the fact that it's symmetric, you can figure out the right answer here. Okay. But at this point, it's been almost 2 hours. Sorry we couldn't find a Lagrange problem on these 2 tests. Lagrange error bound goes like this. Error in absolute value is less than or equal to the next degree term. So the problem would say like, the problem would say, oh, we used a 3rd degree polynomial to estimate this thing, and oh, by the way, we somehow magically know that the 4th derivative is less than or equal to 10, or something like that. 3rd degree polynomial to approximate f of like 0.1, right? So you're going to say the error is less than or equal to the next degree term. So that's going to be the 4th derivative of f of x times x minus c to the 4th power over 4 factorial. So the 4th derivative we magically know is smaller than 10 times, let's just assume this is centered at 0, so 0.1 minus 0 to the 4th power over 4 factorial. And then you just see what that simplifies to. 1 over 2400. Yeah. Ish. Whew. All right. Thanks for checking in, y'all. Good luck on the test tomorrow. Okay, let's all get 5s. If you are at my school, 7:15 small gym. If you're at your school, then wherever you're supposed to be in the morning, please don't sleep in too late. But get yourself a nice glass of water and go to bed. Okay, you need the sleep. You need to be well rested and wide awake in the morning, not on some caffeine-fueled rage at 8 o'clock when the test starts. So get some rest, wake up, have breakfast. Good luck tomorrow. I love you guys. Get 5s. See you next year. Actually, I hope I don't see you next year. I hope you're not in calculus next year because you passed the AP exam and got a 5. Have a good life.